hard to see.
If you have any questions, just contact Abby Scholler. Happy to help.
If you need help, contact Jax.
Yeah, Jack's got,
Jax is a beast at this.
or Garrett, he's yoked.
And a short king. I'm yoked.
I'm gonna pass out notes to you guys.
Your notes out.
Do you put these on YouTube?
Yeah.
Yeah. How many subscribers do you got?
I don't know.
I was the other day, you have 10.
Really?
Yeah.
110.
I had the lamest YouTube channel ever. I had some random person like a video recently, and I'm like, I probably should make these. Somehow try it or something.
Unless
Yeah, there might be a little sketch.
Oh, whatever. It's not like
I just realized they can hear all our
if
conversations.
people are really watching my
Math.
Algebra 2 videos, like I think they like.
Cool.
What are they doing in mine?
Yeah. I mean, unless you're actually in Algebra 2 class, then you should.
Yeah, all you creepy people.
Yeah.
It was kind of funny. I had so just for my online students, they have to upload their like their work to. You guys had to do it in virtual school. You had to upload
Yeah.
your like problems from your test.
Yeah.
And so just to practice, one of my check-ins one day was to upload your notes from the day, like just to show me that you're able to upload a photo. And I had a student write, I don't take notes. And she took a picture of herself and a stuffed animal. So I was like,
What a savage.
well,
What a savage.
I mean, it's not in this class, but it was fun.
How do you
I'm
not
gonna
take
say.
notes? I feel like you would.
Just memorize it.
Yeah, I know, especially it was in geometry, so you think
Yeah.
there's a lot of notes to be taken.
Geometric shapes.
Okay, so if you haven't done this already, if you guys want to look at the warm-up question, we're talking about slope today. And if you notice our notes aren't really that long, the back side of the notes are graph paper for our homework. So I tried to do double duty, not waste another tree.
Thank you.
Save big money in arts.
That doesn't make sense.
Yeah.
If any of you guys are interested, I'm using the green pencil today. Or like how Beauty Guru is, I'm using the green.
I think you should use. I'm using color
I
1
mean-
to peach.
I'm getting a camera for my birthday, so
Are you gonna vlog at school?
no, I'm not gonna vlog.
Why?
I have to take it for FFA because you know I'm the reporter.
Ah. Okay.
Alright, so I want you guys to do the warm-up without a calculator. The reason for that was because I want you to look at a problem like that and kind of think about what it actually means and not have to depend on a calculator because it's really easy to punch something in wrong and get the wrong answer. So just that, like, conceptually kind of what you can picture that to be so that when we're doing problems like this, so you don't have to grab a calculator for things I consider to kind of be kind of more easy computations for you guys at this point. So, like a problem like this, when I'm first teaching negative numbers, I explain it as -4 minus 3. So I go down 4 and down 3 more. So how much have we gone down? 7. So this would be a -7. So just thinking about those negative numbers as like values, like an elevator, as money, as yards on the football field, something that makes sense to you, temperature, whatever it happens to be, that it would help you to understand the concept a little bit better. So 5 minus a -1 really becomes what? 6. How did you get that? Do you think?
It's opposite.
Yeah, those double signs, I like about thinking of them as 5 plus 1. So this would just be 6, so that becomes an easy addition problem. So subtracting a negative isn't really anything we want to do, you change it just to addition. And then finally the toughest of these is -7 minus a -2. So I'm going to kind of apply this property, the double negative. But now this time, if I drop 7, but then it goes back up to, how much total have I gone?
5
5, and it'd be,
negative.
so the bigger number is negative, and so it kind of the negative wins. So if that was like temperature, or that's weight loss, or yards on a football field, we're still negative. Okay? So, we're gonna talk today about slope. Do a bunch of different things with slope. Yes, we will watch slope dude at some point here.
Whoa.
Yeah, man.
I know. And then we can try and find time to get outside as well. So, slope, the like mathematical definition of that is the average rate of change. That's kind of a fancy way to say slope. Probably the way you think about it most often is how steep a line is. So like the steepness of a line. So is it really steep? Like it would be hard to walk uphill, or would it be really dangerous to sled downhill, or would it be real gradual? And if you're doing something like riding a bike, the slope matters to you. If you're going really steep uphill, that's going to matter, versus really steep downhill, that's going to matter to you. You kind of want to prepare yourself for that. So the slope formula we use, anyone remember it?
N equals Y.
Y2 minus Y1 over.
Yeah, that was close.
So this is the slope formula. That's y2 minus y1 over x2 minus x1. So that's a formula you're going to want to memorize if you don't know it already, just by jogging our memory. We also can call it rise over run, which we talked about last time. But this is used more when we just have coordinate points. So we just have two coordinate points. This is the formula we would use. And so that's what the point of the next thing that says the coordinate points. Those are the points the slope goes through. And sometimes you see actually people out in like on a construction site figuring out the slope of a line. They use this like a little tripod. It kind of looks like they're taking a picture, and there's another guy like up on the hill. And they're figuring out the slope of the line. It's kind of those end coordinate points they're using there. So here's where we kind of get into our slope dude a little bit. So thinking about one of the rules on that video, which the video is so silly, but there's a lot of good things that are said on the video, which we'll show in a second here, is the fact that slope dude, do you guys remember, they say in the video, what's that? Oh, sorry. Just points on the line. So one of the things with our video is that slope dude always travels eastward. So he always travels from left to right. And that just helps us to understand the perspective that happens when we're thinking about, are we going uphill or downhill? Are you good? Okay. We're already on to the next thing already. You get ahead. All right, so positive is an uphill slope. Again, from left to right. So this would be an example of if we're going up to the right, we'd be walking uphill. So we'd be walking up a steep hill in this case. So if you want to show like a little hiker or something, you'd be going uphill, work his way up to the right. So from our video, we'll see that in a second. Then negative would be our downhill slope. So it's downhill to the right. I'll put a little sledding guy on here. Then we have zero slope. What do we say that one is? What does that look like?
Flat.
Flat. So totally no fun. So, you know, your mom takes you to the lamest sledding hill ever. It's just flat, boring, zero fun. The horizontal line. And then finally, the complete opposite of that is totally crazy, insane hill, like basically we're sliding off the side of the building. And that would be undefined. So that's gonna be a vertical line. Now, slope is typically a fraction. If the slope is zero, where's the zero gonna show up in the fraction versus undefined? You guys remember the difference? Where's the zero gonna show up in the fraction? If it's zero and our answer is zero, where will the zero be in our fraction? Versus undefined. One of them, depending on where the zero is, your calculator gives you an error. Which one is it? Do you guys remember the difference? Yeah,
Zeros on the bottom of undefined.
oh, which one?
Zeros on the bottom of undefined.
Yeah, undefined, zeros in the denominator. You can't divide by zero. That's the Cookie Monster problem on if you ever ask your Siri phone, what's zero divided by zero, and they start talking about having zero friends and
Yeah.
zero cookies. So you can't divide by zero. You can't break something up into zero parts. Like, you can't do that. But we can take zero cookies and spread it amongst all our friends, and we all just don't have any cookies. But we can't take cookies and then split it amongst zero people. So you can't divide by zero, so that's considered undefined. That's when we start swearing in math class, versus zero being on top. So that helps. It's like a number on the bottom. Here it's a number on top. And I'm gonna pull up Slope Dude.
Yeah.
And we'll watch the Slope Dude video. And then we'll continue on with our slope notes here. Tara, don't forget about time for you, okay? So, I know. So,
Look at him. What a cutie.
Counts. Does he have a mustache?
I've never seen him so close.
Right? Wow. I love this.
Grammarly is
good.
great.
now even Slope Dude has ads.
I would
Wow.
recommend Grammarly.
How many views?
We get it for free within the school, so.
This one has 409,000 views. From 2000.
14.
Whoever disliked it,
372 people.
they need to get out of here.
All right, turn off some lights here for Slope Dude. Turn back on that.
Wish I had some popcorn, you know?
And I think you've all seen him before, but maybe not.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive, puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now we can look forward to the downhill. On the way down the mountain, says, nice, negative, nice, negative. And now after downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead. And all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the Adventure Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined. The uphill is the slope of the positive number, the downhill is the slope of the negative number, the flat part is the slope of zero, and the straight up and down or vertical part is undefined. This has been the Adventure of Slope Dude. Thanks for viewing.
You're welcome. That was so fun. Get out of here.
Standing ovation.
Yeah.
Quality writing makes your school.
You're both proud.
Grammarly is great. I would recommend.
Yes.
So, as silly as it is, Slope Dude, for whatever reason, sticks with us. So, like, one of those things that just helps you remember how to do these. So, we're talking about how to find the slope from a graph. Now, when we find a slope from a graph, we don't have to use the slope formula, the y2 minus y1. We can just use rise over run. So when we do that, we're basically going to,
What is that?
and I took one, there we go. So we're gonna do rise over run. And basically what we're gonna do with our graph is we're gonna pick 2 points out of the graph. So I can just pick 2 points that the graph goes right through and use that to do rise over run. Now, sometimes the drawing is not great. I don't know if all mine here are really good in terms of being able to go through a coordinate point. That's what the thing here. Board is a little dark for them, or too bright, maybe. So we can do rise over run. Once we do rise over run, we can simplify. We always want to simplify slope so that we can make sure we can compare slope more easily with other slopes. So like in letter A, right away I look at letter A, so if you can't tell, A is that little one here. It's this, on mine it's red, but obviously in your paper it's not. So A is here. And it's going, remember, Slope Dude always travels eastward. So A would be either, what, positive or negative?
Negative.
A is going to be negative already. So right away, I can already say A is going to be a negative slope. I know it's going downhill because he's traveling eastward. So nice negative. And I'm just going to pick a couple of points that are close to my line. And like I said, this one's not great because I didn't draw like big dots for you, but sometimes picking like the intercepts is helpful. So like I picked the 2 intercepts. And the rise over the run, the rise is how much I go up or down. So again, we move eastward. So we start from the left, go from this point to the next. I actually have to go down 2. Let's go to the next intercept. So I'm going to go down 2. And then I'm running to the right, and right is positive. I go right 2. So down 2, right 2. So negative 2 over 2. So my slope in this case would actually be a negative 1 over 1. Now Now, had you not picked those 2 points, and you picked points further apart or closer together, once we simplify, we end up with the same answer either way. Okay? So letter B is a little bit trickier because I didn't do a very good job of drawing it, so it's my fault. So it just depends where we wanted to go through. I don't know, should we go the beginning and the end, maybe, kind of where the arrows are? I don't know, let's do that. Now this one, is it gonna be positive or negative?
Positive.
Positive, we're going uphill, up, positive. And I need to go up to where I'm level, so I'm gonna make a little step out of this, 1, 2, 3, 4, 5, it looks like. And then I'm running across, positive. 7 and 9. Is that right? So 16.
That's what I got.
16. So I got 5 over 16. Now, if you guys pick different points, you might have got something a little bit different. Like, so you got 1/3. 1/3 is actually very close to 5 over 16. So he got 5 over 16. So he got 1/3. 1/3 is the same as 5 over 15. So it just depends where we like pick our points to go. So understand that these are really, really close and it's not always super accurate. So 1/3 is really close to 5/16, so I'd be fine with that. My drawing's not perfect, so sometimes we have to go with it a little bit. So there might be a range of values that make sense. And then finally for our green line, our C is a steeper uphill. So I already know that this number is gonna be a bigger number, it's gonna be steeper. So I'm gonna use the intercepts again. And again, if you use something different, it might be a little bit different answer. This time I go up 7 and over 3.
Yep.
So 7 over 3 is obviously bigger than 1/3. So this is a steeper slope, 7 over 3. But like I look again, so like Matthew had already done this, and he got 2, which is 6 over 3, which is really, really close. So again, it just depends which points you choose. All right, so let's flip the page here. And again, a lot of this stuff is stuff we should have learned at some point in algebra and geometry, so it should be reviewed, so hopefully it is. I'm going to try and go a little bit slower than maybe I usually would, just to make sure we're all on the same page with things, but oops, I don't need a parenthesis there. So we're going to put our 2 points into the equation and then just simplify. So they're asking us for the slope of these 3. So if you guys want to try a minute to do the slope, so just to remind you guys that you're doing y2 minus y1, and then x2 minus x1 on top of each other, and then dividing it. So examples 1, 2, and 3, if you guys remember how to do it, otherwise I'll get example 1 started here in a second. So I set my equation, and then I have to be careful about like the signs.
I did that.
Oh, okay, I was looking at your numbers,
Yeah.
I'm like, what numbers are you?
I didn't see the one over here.
I
Yeah.
I just making up numbers.
Yeah, I'm just going with the flow. Just doing my own thing.
attendance was.
How did you find a minus?
Okay. So in our first example here, we did 4 minus 3. And then after that, we did a -6 minus a -2. So this becomes a lot like the question, like in the warm-up. 4 minus 3 is 1. -6 minus a -2 becomes -6 plus 2. So I end up with a -4 there. So this slope would be a -1/4. I can also figure that out had I graphed it, but it's easy enough to do the formula, so we can just stick with that. All right, the next couple here. So I do 4 minus a -2 over 3 minus 1. 4 minus a -2 becomes 4 plus 2, so that's 6 over 2. So that ends up being 3. And then finally, subtract -3 minus a -3. And then 4 minus 6. -3 minus a -3 becomes -3 plus 3, which ends up being 0. So 0's on the top, what kind of line is that?
Horizontal.
It's a horizontal, it's a 0 slope. So this one would have a 0 slope, this would be 0 fun, be flat line. You could think about what the way the graph looks there. All right. So these next two problems are asking us to find a missing part of our slope. Once we do these two, then we'll take a little break. So in these problems, they tell us the slope. So they tell us the slope is -5, and there they tell us the slope is 6. But if you notice, they give us all the information except for one part of the coordinate. So we're missing the r in each of these cases, and they might call it x or y, depending. We have to find that missing coordinate, so we have to find r in this case. So what we can do then, hold on, Nikki, down. Yeah. Okay, bye. Okay. So in this problem, we want to use our slope formula. So our slope, our m, is what? What have they told us about m?
-5.
Yeah, they gave us m, it's -5. So I can put that in place of m. Typically, they don't give us m. Then they want me to find the r. So I'm going to put in what I know. So I know these are my y values. So -4 minus 6 goes on top. And then r minus the -2. So I have to figure out what r is. So I have a -5 on top. I have a -10 here, and then I have r plus 2 on the bottom. So there's a few different ways we can figure this out. We can do some guessing and checking. That works fine if the numbers are nice and easy to work with, which is this one it is. Does anyone have another way to do it other than guessing and checking? Thoughts on how you can come up with that? No. right, what if I do this? So if I make it look like that instead. Does that help at all?
Can you do like the cross?
Yep, now we can do cross multiplying. As soon as I make them both fractions, I think you guys are pretty good at cross multiplying, but until they're both fractions, I think we're kind of like, kind of puzzled. Now again, some of you guys might have just been able to figure it out by looking at it, but not all of us are good with that kind of mental math. So the negative 10 times 1, and then negative 5 gets multiplied by the r plus 2, and then we're able to solve this. So this is 0, and I get a negative 5r, this goes away. And r is just going to be 0. All right, so if you guys have that one, once you see if you guys can try the next one, we'll talk about it here in a second, and then we'll go outside. Not very long. Quick outside trip. If you can set up this next one, again, I suggest setting up as a proportion. All right. Does this work out to be a nice number or no? No. So this one would be really hard to guess and check on, because most of us don't guess and check well with crazy decimals. So, again, here's my 6 over 1 is my n. I'm just going to make it a fraction right away. Do 9 minus 5 over r minus 7. And then with 6 over 1 equals 4 over r minus 7. And we can cross multiply. And distribute here. (42). Move that back over. As much as we want it to be, 6 does not divide into 46. So it ends up being 6 goes into 46, 7 times right with a remainder of,
Repeated 6.
yeah, 7.6 repeating, or 7.7, right?
Right.
Right, 7.6 repeating, yeah. Okay, so we're gonna take a quick break. We're not gonna go outside for very long, just maybe like 10 minutes here quick. We'll come back to the second half of the video here in a second.
We'll see you shortly after this quick intermission.